Hi folks, we're going to take a look now at number 10 from the Unit 4 assignment. So let's see what they tell us. They tell us that the interior angles of a triangle are 20, 40, and 120. And they say the longest side is 10 centimeters longer than the shortest side. Determine the perimeter of the triangle. So what we're looking for, uh, obviously, are all the three side lengths so we can find the perimeter. But we notice here that we have a triangle where only the angles are given. Not enough to solve a triangle, but there's this extra piece of information. So hopefully that'll be enough to help us solve the problem. So first, let's draw a triangle. Okay. And notice how I'm trying to draw them with different angles. So a big angle here. So we'll call this one 120. And between these two, this is the larger one. So I'll call this one 40 and this one 20. Okay. And this does make a difference because it'll be nice in my triangle to help recognize which is going to be the longest and shortest side. So they say the longest side is 10 centimeters longer than the shortest side. So let's call the shortest side X, which is the one opposite the smallest angle. So if this one is X, the longest side opposite the biggest angle is going to be X plus 10. Okay, and I'm going to need all three sides. So, I'll have to give a name to this side here. So I'll call it Y. And I see that I've got two variables. Even though I'm looking for three sides, I've got two variables. So I may have to solve a system of equations. So let's start by figuring out what we can use. Well, we're looking for these side lengths, and I have all the angles, so it makes sense to use the sine law. All right, so the question is which two sides am I going to use? Well, here, I'm going to choose to work with these two sides, because that means the equation I'm going to create is only going to have one variable, which is going to make it a lot easier to solve if I don't bring in the y, at least not at this point here. All right, so let's create our equation. So we'll do x over the sine of its opposite angle, which is 20, okay, is going to be equal to x plus 10 divided by the sine of its opposite angle, which is sine of 120. Okay, and now we have to solve this equation. Now I solved a similar question, I would say a tougher question this earlier on, and it was a tougher equation. So what I did is I just decided to estimate these numbers to help solve the equation. But this doesn't look so bad. So I'm actually going to keep the exact values and only approximate at the very end. Okay, so let's do that. So I've got an equation. I have these expressions in the denominator. I would prefer not having in the denominator. So I'm just going to do a little cross multiplication. I'll multiply sine 120 to the left. Okay, so we have sine 120 times x equals, and now I'm going to multiply this to the right hand side. But you have to be careful here. This sine 20 is multiplying the whole numerator. So I have to distribute to the x and the 10. So it's sine of 20x. Whoops, I should have put the bracket there, plus 10 times sine of 20. Now you notice here in terms of convention, we usually like to put any coefficients in front of the variable. And remember, sine 120, sine 20, they're just numbers. They're the coefficients of x. But when we've got these two numbers being multiplied, we tend to put the integer or the real number in front of the sine value. So just a bit of convention for you. All right, so now we have a much easier equation to solve. And so I'm going to solve this like I would any linear equation. I've got x variables on both sides of the equation. I'm going to collect them all to one side. So I'll bring this one to the left side. So we've got sine of 120 times x minus sine of 20x equals 10 sine 20. And you see I'm not doing any approximations here. But now take a look at these two expressions. These are just two monomials with the variable x. How do we add monomials that are like terms? Well, we just add their coefficients, or in this case here, subtract their coefficients. So I can reduce this to sine of 120 minus sine of 20 times x. Okay, so exactly like if I had 5x minus 3x, what is it I'm actually subtracting? The two coefficients. I'm doing 5 minus 3 and then times x to give me 2x. Just doing the exact same thing here. So here equals 10 sine 20, and now I can just divide out this number that's multiplying the x to both sides. So I have 10 sine 20 all over sine 120 minus sine 20. And that's not too bad an expression to put into my calculator. All right, so let's do that now. So here we've got 10 times sine 20 equals, okay, and divided by, now I've got a subtraction here, so I better open up a bracket. So that's sine 120 minus sine of 20. And what do we have here? 6.53. All right, so we've got one of the side lengths. All right, got this one here, x. But of course, the longest side is just x plus 10. So that's going to be 6.53 plus 10. So 16.53. But since I need to find the perimeter here, I also need this side length y. But now that I have the other two sides, I can just use the sine law to find y. Okay, so let's set that up. We have y over sine of its opposite angle, which is 40, equals, and I'll use this one here, 6.53 divided by the sine of its opposite angle, which is 20. So y is just equal to 6.53 times sine 40 over sine 20. All right, so let's calculate that. So I already have the 6.53 here. Okay, so times sine 40 and then divided by sine 20, and that's equal to 12.27. All right, and of course that's not the question that's being asked. I have to find the perimeter. So let's finish off the problem here. The perimeter is just going to be the sum of all three sides. So 12.27 plus 6.53 plus 16.53, and that's going to be, so we got this plus 6.53 plus 16.53, and we have 35.33. If we keep it to two decimal places, 35.33. Okay, and since we were working in, well, if we look up here, working in centimeters, the whole thing is in centimeters. All right, so nice little problem. Let's take a bit of a recap here. So step number one, to get ourselves a diagram and input all the information we know, not just the angles, but also the relationships between the side lengths. And the relationship we had was that the longest was 10 bigger than the shortest. And that's what allowed us to set up an equation using the sine law that had only one variable, okay, which I was able to solve. So once I was able to find those two sides, I can then afterwards go and solve for the missing third side before finding the perimeter. Okay, that's it for this one.